Hey, welcome back to my bench. This week we got something a little unique and different. This is how it arrived. This is a Nikko NR-700 receiver. 40 watts a channel, AM FM digital tuning. Not much to say else to say about it. It's pretty heavy. It is quite heavy and quite big. But this is how I received it, all wrapped up. I haven't even opened it up yet. And I was just going to go through and open it now. And oh, look at this. This is what the seller gives me. Little treats. I love this. Isn't this nice? What do we got today? I bought other things off this seller before on eBay. I don't usually get things unless they're a good price. And I bought before from him. This is Polish. This is Polish. It looks like a coconut dipped in chocolate. This one's Polish as well. This is a lemon. Check this out. This looks good. Yeah, lemon chocolate, right on. I love chocolate. A little smashed up, but who cares? Anyways, that one's for later. Let's open this up and have a look. The seller, or previous owner, said it's got a problem with the... here, let me read his comment. Shouldn't be making a video with my mouth full of candy. FM works fine. AM is very weak, almost none. Problem starts when switching from FM to AM. Tuning is stuck. Signal display not working. Amplifier works fine. Can be used as a FM only or as an amplifier, no problem. And it was listed as is for repair, which is what I always go for. So it looks like we got some tuner problems. I'm guessing if we got a problem with one of the tuners on a digital receiver, usually it's a power supply problem. A lot of the problems can be traced back to power supply, because power supplies are essential for proper operation. I should have unwrapped this before. Let me pause it and I'll unwrap this. I don't have to waste your time on this. So there we go, I got the wrap off of it. And he gives you a little thank you card from Antiquium. And a little thank you card there. That's really nice. Thanking me for my business. Here is his card. I don't know if I should be showing you this. It's got his name and number on it. But he is a good seller on eBay. And I bought things from him before and had positive experiences. So yeah, he sells all kinds of stuff. I usually go after the broken electronics, or the the vintage stuff that needs repairs, and I put offers in. If he accepts it, he does. If he doesn't, he doesn't. But yeah. So let's have a look at this. Looks very nice. Needs a little bit of a clean. Very nice. Let's power it up and see what it does or doesn't do. Let's get some speakers on this first. Okay. Some power. It does have an AM antenna. Is it hooked up? Yes, it is. Okay, good. So that's kind of rare to find an AM antenna on a piece of equipment. Usually they're gone. They're ripped off and thrown away. But it's just a loop, wire loop. Let's look at the back here. We got phono, auxiliary, 2 tape loops. We got a 3.15 amp circuit breaker. 2 courtesy outlets and then 2 sets of speakers. That's all there is. Okay, we got it plugged in. We're set on A, I believe. Yes, we are. Okay, let's turn this on. FM. FM muting. AM, FM. Okay. I don't have any antenna here. Took something up. Getting 4 bars on my signal meter, but there's no station. Display is kind of dim too. Maybe that's an incandescent lamp behind there.
Dans une communauté dans les Andes, petite communauté.
Is a small step forward.
Meanwhile,
Picking up stereo. Auto. Let's do auto scan. It seems like it doesn't know how to scan by itself. Is that a scratch? There's a scratch here. It goes... It doesn't know how to scan. Even the muting's not working now. Something's messed up with this tuner.
all of the other range.
Okay, let's try AM. Should be a station right here. There's nothing. It's silent. AM's dead. It's not picking up any stations. Oh, now it's locked up. I can't go up or down. AM's locked up. Back to FM. And it says 109.0, which is incorrect. And we have no background. What do we got going here? The tuner's locked up on both, so I don't know. There's something messed up with the control of this tuner. I suspect it's probably maybe dirty power supply caps, letting dirty power into the tuner, maybe tripping it up or locking it up, or it could be a lot of things. Well, I'm just speculating right now. So let's open it up and start looking at problems. What could it be? And see if we can find the issue with this thing. Maybe it's something simple like high ESR caps. Pull the lid off. Alright, off she comes. Looks like a low hours unit. There's no smoke stains or dirt stains from heat. Not a lot of stuff going on here. So right on top we have all of our FM AM tuner boards. And let's see. To move the camera, hang on. Down here we have power supply board, main transformer, main power switch, and what else is going on here? A little bit of heat sinking, not much. 40 watts a channel, that's what I'm understanding. And then we got some audio boards underneath. So this thing has a removable bottom. Let's take the bottom off and have a look as well. So I'm looking at the schematic here, and there is 4 voltages coming off the power supply board, going with this to the tuner board. I believe it's this cable here. This is the only one that goes between the power board and the tuner board. And it is a 8 conductor. Let's see here, what do we have? 1, 2, 3, 4, 5, 6, 7, 8 conductor. That's what it is. So there's supposed to be 26 volts, 120, but I believe it's 12.0 because it's so printed tiny on this schematic. 5 volts and 9 volts. So let's turn this on, see if we have all our voltages. We are on tuner. Okay, we should be good. Let's see here. What do we got on these first two? .3. That could be our 9 volt. 26.16. That's our 26 volt. 12.9. Last one is our 5 volt through 5.3. They all seem good except for this first one. It seems low. Our 9 volt is a little low. I'm wondering if that's from loading. Let's check this without a load on it. And it came back up to 9.5. So we might have a problem on our 9 volt line. Or it could be a power supply issue. Maybe that 9 volt is weak. Let's plug this back in and check it again. AM. Yeah, it just locked up again. Now it's displaying 110 megahertz. This power supply board is under this. I think the first step is I'm going to have to pull a tuner board out to access the power supply board and see. Oh, this is the power supply here. And see if there's any problems on that power supply. So I might have to take the front panel off, take the display panel off, the display board, and take the tuner board out. And then we'll take a good look underneath, make sure there's nothing going on under there. So here we go with the tuner removed. I was just having a little quick look at the back. And on this connector here, the power connector, I do see one cracked solder joint. And yes, that is cracked. And it's on one of the ground. I think it's the last one I checked, plus 5 volts ground. So that could be cause of the problem. Maybe it's not getting it. Maybe it's got a dirty ground. Looking at the rest of the board, I'm not seeing too much, but I'm going to check it over very carefully with an eyeglass just to make sure I didn't miss anything. There might be a few other spots. There's one spot here. There's one resistor here that's cracked, and this is looks like it's a dropping resistor for the LED display. So that's a minor thing, but I'll go through it and I'll check that out. And then we have full access to the power amplifier, which everything looks good and original and intact. Doesn't look like anything's been changed. A little bit of dust in here, I could clean that out. Protection relay, we can clean that as well. But everything else looks normal. I am seeing some circuit glue here around some of these big capacitors. So I'm going to clean this out. This Zener diode here has some corrosion around it. I'll clean that out. Some more here on these big caps. Although I don't see a lot of corrosion, I'm still going to clean this stuff out. Alright, just to give you an update here what I've done. I have removed the tuner board, and I went into the power supply, replaced 2 capacitors that were weak, low ESR or high ESR type stuff. I checked a bunch of other ones, they were good, so I left them alone. Replaced 2 capacitors, power supply. I replaced 1 capacitor here beside the phase lock loop processor. So I took out, there was a power supply cap here. It was a 330 microfarad, and I replaced it with a 1200 just to bump that up. There was another 2 caps underneath on the audio board that I replaced. They were power supply caps for the phono amplifier. Unrelated, I know. And I did some soldering on some bad connections. And I still have 3 caps here that are flooded with that glue. I still have to remove these 3 caps and clean up around the capacitor. It's all flooded with glue here, and I think it might be affecting some of the other components. But I just threw it back together just to have a little test here. So let's give it a test, see what's going on. We're on FM. FM's working. AM.
It's capable of doing it. You don't have
Oh, AM's working now. I don't know what we have for signal.
Teacher says, Devo, you still have the book I gave you. Let's see.
In adults in their 60s and 70s, studied.
Sounds kind of weak, but it's working. That's a good.
As soon as possible for those groups because they're
I switch between FM.
healthcare workers.
It doesn't lock up. Appears to be working good.
Larger phase 3 trial results expected in the cup.
Scanning. I don't know if it'll pick up anything by scanning. It's kind of weak. So it looked like we fixed whatever was wrong with the AM.
Says ultimately they want more on climate change added.
But I still want to pull these capacitors, these 3, and clean them out. I think that might be something to do with what's going on here. I noticed that the top board had no dust on it. It was like it was very clean. I removed the top board. The amplifier board underneath was coated with dust. So somebody has been in here and they've tried to get this going. And I can tell on the other side of the board somebody touched up some solder joints here and there. Maybe there were some cracked ones and they're gone now, but it appears it's working now. So
They arranged a meeting, and during that meeting, they attacked him, jumped in and stole the PlayStation 5.
RCMP are warning about
the pots sound
violence
clean.
over video game consoles.
Switches sound clean.
Kathy, Global News Radio.
All the lights are functioning, except for this one. No, they're working. Lights are all working. The only other thing that I didn't do, I should have done it right from the start, is check the DC offset on the amplifier. Let's do that right now. And I'll have to set up the bias idling current. So here's 41 millivolts. It's pretty acceptable. This one's minus 55 millivolts. And I don't believe there's any adjustment for the offset. I believe there's only an adjustment for the biasing. And I don't even see the pot for biasing. When I remove the tuner again, I'll go in and do the adjustments for the biasing. They have a little cutout hole here, but it's kind of impossible to get your probes in there and clip them on. So when I take the board out again, I'll do that. But so far it's looking good. AM's working. It was working. Okay.
In a span of just 24 hours this week, 3 prospective console sellers in the city were attacked.
Then keep it to ourselves.
No antenna.
You're investing in the most specialized children's home.
Okay, so I'll pull that tuner board out one more time and get that cleaned up, and then do the adjustments, and we're call her finished. Alright, so I discovered another problem with this receiver, and it is the power cord. It has several cuts in it. Let's see. It looks like some animal maybe was chewing through it, maybe a rabbit or a rat, who knows. But there is, let's see, there's 1, 2, 3, 4 spots where there's copper showing through. Bare copper. That's unacceptable. I'm gonna replace this with a new power cord. And it's pretty simple. Let's pull this out right now. And there's 2 connections right here, right on the bottom of this bottom socket. Get rid of this zip tie. And you can see the wiring here. Right here on the bottom here, there's 2 connections, so that'll be easy to fix. This circuit breaker is on the primary side of the power. There's no fuse. I guess it's just a 3.15 amp circuit breaker. This new plug I'm putting on is polarized, so the the blade that's small, or sorry, the blade that's wide is your neutral, and the blade that's narrower, that's your hot. So that's the side we want to connect to the power switch, and the neutral side we want to connect to the other side. If you look at the schematic, I'll give you this schematic's useless for a demonstration because it's so tiny, but we want to get the hot wire onto the power switch. That's the first thing we want to see, and the neutral goes to the transformer winding. Yes, there's the one that goes straight to the transformer winding. That's your neutral. Now you can use an ohm meter to ohm it out, or a continuity tester to figure out which one is which, but just remember that's the way they have to go nowadays. Back 30-40 years ago, they didn't have quite the electrical safety standards that they do now, so that's why you see a lot of these older equipment with the two-prong plug that's not polarized, and you can plug it in either way, right? Alright, so every receiver is going to be different if you look at the wiring and the schematics, so that's why I suggest pull out a schematic for your receiver. If you want to do this power cord replacement, you have to figure out which side of your line cord is switched and which one isn't. You want your hot to be on the switch side, and if you look at the plug, the wide blade is your neutral, and if you look at the wire coming out on this side has ribs on it. That's your identified wire. If you look at the hot side, the hot blade, you'll see that's smooth, right? So your identified wire is always your neutral. So I looked at the circuit of this one. The neutral is this white wire here. This wire goes straight to the power transformer, and the other one, the purple wire, goes to the switch, and then it comes back to the circuit breaker, and then it goes to the transformer. So we're going to do this. Let's put some heat shrink on these. Even though they originally didn't have heat shrink, I'm just going to put heat shrink on after, just to make it safer for the next guy that's in here. So neutral goes to the white, so I'll wrap this. It's a little tricky here because there's not much room to work. And we can solder that one. There we go. And if I'm quick, I can probably put the heat shrink on. No. I'll wait till it cools. Let's get these wires out of the way, and then let's do the other one. This one's a little tougher because it's in behind a bunch of other wires, so I gotta make sure there's no shorts. Where's my tweezers? Wrap that around best I can. All your wire soldered connections should be wrapped before they solder, just as a mechanical connection before the electrical. You can't just tack wires on expecting the solder to hold it. So let's do this properly. Oh, that's tough. I should have done this one first. Okay, we're on there now. I'm just worried I might not be able to get the sleeving over. Push it down. There we go. And you want to flood that good with solder so it's okay. Those two are in. Just let that cool down and then we'll get our heat shrink on there. I believe one of the safety standards they have today is that all the primary electrical joints need to be insulated with sleeving or heat shrink or something. But that might I'm not sure when all these changes were made, but there's always changes being made for safety. Can't get that on there. I'm gonna have to I know you can't see what I'm doing, but I'm trying to get that sleeve on that joint. There it goes. And just rotate it. And it kind of just wiggles up. Good. We're going to leave some slack on the inside a little bit. Give this a good squeeze. There we go. Perfect. New cord. One last thing, just got to zip tie these just so that they don't move around, because anytime you have a wire that's flexing or moving, it's potential for a break. Zip these together and that ties them together solid. Perfect. Okay. Alright, I've had the receiver probably on for about half an hour now, and it's just idling. And I want to measure the bias current on the output transistors. Measuring this channel here on the left, I don't know if it's left or right, it's measuring at 8.8 millivolts across a 0.47 ohm resistor. And I'm going to measure the other channel here. There is no adjustment for biasing on this amplifier. And that channel measures about 8.5 millivolts. So they're pretty balanced, they're pretty equal, and I think they're acceptable. I could calculate how much current is going through those resistors, but I think it's doing good. It's not even barely getting warm. And like I said, this amplifier has been sitting idle for about 20 minutes, half an hour, so I'm just going to leave that alone. There's no provision for adjusting it. There's no potentiometer. And if you look in the schematic, there is no mention of how much current they expect to see. They have the test points listed out here. But there's no indication of how much current should be going through those resistors. And sometimes they do have it on the schematic. They have the idling current, but not this one. And I don't have a service manual either, so I'm just going to leave it alone. Well, I can't change it anyway, but it's just going to be measured and put back together. So I just wanted to measure that to make sure we're not out. Now I can put the tuner back in and button this up. Potentiometers switches I did not clean. They behaving quite nicely. I didn't hear any scratchy noises out of them, so I'm not going to touch them. This power switch, I think somebody's had it apart. But it seems to be working fine now, so I'm just going to leave that alone. Other than that, everything else is pretty normal. He's doing well. I did replace, I'll show you here. I did replace a bunch of capacitors in the power amplifier. I did find 2 of them that were bad. They were 220 microfarad and they measured out at 47 microfarads, and I had to test them out of circuit. So I did find a couple bad ones in the power amplifier. So those are now replaced with audio grade caps. So that's the extent of the work on this amplifier. I don't know if you can see this but this volume pot. If you look at the back side of it, there's a disc. You can see it's broken, it's split. And that is the detent to have the feel, you know, but it's mostly broken and gone. So I'm just going to remove that. It's really serving no purpose there anymore. Now it's silent. There's no fixing that. That's split. It's a nylon part. So, alright, so I got it all back together and I did a final test and it's not working again. So whatever happened when I pulled this board out and put it back in, maybe there's a bad connection, but I'm not sure about that. See, right now it's locked up. It's on FM. It says here 124.0 megahertz, which is obviously wrong. If I switch it to AM, I get no tuning up and down. Switch it to FM, no tuning up and down. If I take it off the tuner and go back, it starts working. Okay, go to FM or AM and I go up or down. It goes one step and then it locks up. And the AM is sounds like it's working. Let's see if we can get a. So there's something going on with the phase lock loop of this thing. I'm not suspecting anything in the tuner sections. There's an LA1245 AM receiver chip. I don't think that's a problem because it was working. I think the problem lies here somewhere with the phase lock loop and the microcontroller for it. I'm going to check voltages and I'm going to check This chip has its own oscillator crystal, and there's no indication what it is, how fast it's supposed to be oscillating. And the crystal itself is not marked. I think it's something like 4 megahertz, or who knows, but I'm going to see if I can figure this out. Because right now it is not working.
Country 103.9.
Very interesting. So I'm going to keep poking at this. So just to give you a little update here, I didn't make any progress, but I just want to show you what I'm up against. What I'm doing, or what I've done, is I've gone through and downloaded all the data sheets for all these chips. There's 1, 2, 3, 4, 5 different chips for the chipset for this phase lock loop. I'm not worried about the tuning end of things because we know that end works. It's more about the control here that's not working properly. So I downloaded these data sheets and printed them off, and I'm just going through and doing voltage checks on these chips to make sure that they, first they got a good ground and they got a good power, clean power. And then, like for example, these 4069 hex inverters, I'm just going through and doing logic tests to make sure that they're actually doing what they say they're going to do. And then I'm just going to, I don't know what else to do because I'm at a loss here. And this thing, to make matters worse, all of a sudden it'll start working again on its own. And there's no rhyme or reason to it. It just happens. But I know if I take it off tuner, put it back on tuner, it starts to behave again, but then it locks up. If I put the auto switch in, it works normally. Something to do with this tuning mode, auto manual, because now it's working normally. I can tune up and down, and I can bring in stations. Or it was bringing in stations. Let's see here. Now it's going to make a liar out of me. See, it's very flaky, and trying to troubleshoot something that's so flaky like this is near impossible because 1 minute it's working, 1 minute it's not. So how do I do tests and compare results when I don't even know myself if they're valid? So I'm just going to keep plugging away here, and see, now it's not working. It's just mind-numbing. But the AM does work occasionally, comes in. I don't think it's these switches. I checked these switches, they're good. So I'm starting to suspect it's the phase lock loop processor, which is the UPD 1703. This one's a dash 016, and I have a data sheet for the dash 018. They're pretty much identical chips, but I still have a lot of poking around to do here, so I'm not giving up yet. Alright, looks like I'm making progress here. I found, well, let me go through what I found so far. What I've been doing is I've been checking voltages on pins of the microprocessor and comparing them, between AM, FM, between auto and manual mode, and then when I do the AM tuning, the receiver locks up and it doesn't work. So I'm measuring voltages and I'm trying to get it to lock up and show me what's going on here. And I found one spot here. There's a diode here. It's I can't even read this, it's too small. But there's the mute switch here, and there's a diode, and then it goes to pin C, or connection C. You probably can't see it on camera, but if I had a hard time finding this. But C comes from pin 7 on the microprocessor. And pin 7 on the microprocessor is this one here, station detector, SD. When this terminal is forced high to a high level in auto tuning, auto up, down mode, the scanning is quitted. Okay, A high level signal should be input within 75 milliseconds after a phase lock loop is locked. Now I was scoping that pin and I noticed there was an inconsistency on it. And when the receiver would lock up, that pin would stay high and it would not come back down again. So going back to this, traced the line back here, and I did some measurements around here, and I noticed that this, when it gets stuck, the tuning stops working. It gets stuck in in a high state somewhere by this diode. So it got me thinking, okay, not too bad. I started poking around this side of the circuit where the diode is. There's 2 transistors here. There's a bunch of diodes. This is where the switching happens. You know, there's a lot of stuff going on here. So what I did is I hit it with some cold spray.
My feature properties
And the AM comes back.
Get out of the city and into a 3,500 square foot walkout bungalow on 17th.
Now if I heat this up again,
Complete with 2 large shops. Perfect for the small business owner.
AM goes out. So right here is a problem. I can't pinpoint which component it is. I'm beginning to think it might be that transformer can. But I'm having a real hard time focusing this cold spray. It might be this capacitor, this styrene capacitor.
Those who are deserted and desolate, abused and abandoned, are relying on your generosity.
So I might have to change that capacitor. I think it might be bad. I've never seen one of those styrene capacitors go bad. Just go very low, and then back it comes. So what I might do is pull that capacitor out and test it. It could be one of these 2 disc capacitors next to it. I thought it could have been this variac or this variable diode, variac or whatever they call them, but it's not responding to the heat. The can doesn't seem to respond to the heat, but the only thing that does is that styrene capacitor. I'm going to pull that out and test it outside of the circuit. Alright, so here's the capacitor hooked up and it's out of circuit. And I'm going to spray it with some cold and we'll notice a change. And it goes up very, very slightly. These styrene capacitors are very accurate and stable. And this one comes in pretty close. Let's hit it with some heat. I don't want to hit it too hard because I don't want to melt it. I'll turn the heat down. And we can see it doesn't exhibit any wrongdoing. So is that the culprit or not? We don't know. Okay, so I removed that styrene capacitor, that's C219. I think what I'm going to do is I'm going to remove these other 2 disc capacitors. There's 2 here. There's one here and one here, 10 picofarad, and this one's 0.01. I'm going to test these 2 capacitors as well because I don't know, something's not right here. And if it all else fails, I think I have to pull that can out, maybe try that. Okay, so here's the 10 picofarad ceramic disc capacitor on my tester. And spray it with some cold. Doesn't seem to do anything. Oh, hang on, it jumped to 15. Let's hit it with some heat. Nothing. Okay, so I got the last disc capacitor in there. This one's marked 103, which tells me it's 0.01 microfarads, and it's measuring 16.6 nanofarads, which is considerably off. Let's spray it with some cold. Wow, it dropped. Let's hit it with some heat. Yeah, it dropped as well. I think this cap is messed up. I think this might be the culprit. So when I hit it with heat, it drops. When I spray it with cold, it drops. Let me dig out another one. Here's another one. And it's stable. Hit it with some cold. Stable. Hit it with some heat. Stable. Yeah, I think that capacitor is bad, that disc capacitor. Determined this disc capacitor is bad, and I am going to put in its place, I'm going to put in a metal film. These are a little more stable, temperature stable, and this one's a little more accurate. This one measured out at, let me see this again. This one measures out at 10.6 nanofarads, which is probably well within tolerance, and it's, you know, it's going to do a lot better job than that one was. So let's get this back together and then we'll do a final test. Alright, I just want to go over the schematic as to where I found that bad capacitor. This is the LA1245. This is a one-chip solution for AM tuner. And on pin 18 there's a coil, a capacitor, and then it goes through another capacitor, or several capacitors, then to ground. So this is all a tuned circuit here. And this is what the chip uses to tune in stations. It uses this variable capacitor diode. And this is controlled by a voltage. As you change the voltage across this diode, the depletion region changes, and it actually acts like a capacitor. It's got a high capacitance, and you can change the capacitance according to the voltage you apply to it. Now, this is got a blocking capacitor here for DC, so the tuning voltage is not coming from the chip, it's coming from somewhere else. I think it's coming from where test point 20 is connected, and this line here goes back to the microprocessor. So that capacitor that I changed that was defective was C221, and it's 0.01 microfarad or 10 nanofarads, and it wasn't shorted, it was actually changing value quite a bit. It was faulty. Now, I think this is just put here to stabilize the voltage control line for this capacitor. And I think it was probably leaking. I didn't check it for leakage, but I bet you it was. If I follow this line up, let's go up and follow that line up. Where are we here? I lost it already. Okay. Up and over. So if I follow this line up and over to here, you see we got C201 is another 10.01 microfarad capacitor, and it goes to another tuning diode. So this is the voltage control line for this diode, and somehow this capacitor was shunting it to ground, and I think that's what the problem was. It couldn't tune in with the this defective capacitor here. It couldn't tune the circuit. Now if I go over to the data sheet for the for this chip, this LA1245, you can see pin 18 is connected to the oscillator, and there's your coil, there's your blocking capacitor, the 340 picofarad. That was that styrene capacitor I pulled out first, and then it goes on to the tuned circuit. You can use capacitors to tune it, or you can use a variactor diode. So yeah, this confirms that that tuned circuit wasn't working, so this oscillator was stalled out or killed altogether, and we were getting no output from our AM. Here's the data sheet for the variable capacitance diode, and the one that was in the receiver, the Nikko receiver, was a KB226, and I'll look at let's just look at the packaging of it. It kind of looks like a transistor. It's a CB2-4 package, which is a 2-pin package. It looks kind of like a diode, or a transistor I should say, and they do come in TO92 packages as well. You can see all the different packages, but they're voltage controlled tuning capacitors. So the KV1226 is a tuning, and it has operating voltage up to 25 volts, and it has capacitance at 1 volt of 510 to 620 picofarads. When you put the voltage up to 25 volts, the capacitance drops to 16 to 26. Alright, before I go any farther, I'm going to do a test here before I bolt everything down and find out it's not working again. So I got speakers on. Where are we here? Tuner. Turn this thing on.
To look at
AM's working.
Sophia pointed us to it.
No antenna. FM's working. AM's working.
From this terminal may likely happen regardless because these.
It's auto scanning. It's tuning.
Quote significant.
Indianapolis 500. She said if a woman could put a car in the field.
Seems like it's all normal now.
By their refusing to acknowledge Joe Biden.
So it looks like it was that capacitor was the culprit, and it caused a lot of chaos in the tuning circuits. That was a tough one to find. If I didn't have the cold spray, I don't think I would have found that, because that's not something you would suspect is a tuning capacitor to cause it, to lock up like that. I thought it was a microprocessor problem, but it shows me that I was wrong. You never know. Okay, let's finish wrapping this up. Alright, so we're all wired in for a power test. My dummy load, feeding it a 1 kilohertz signal. I got my scope hooked up, you should be able to see that in the corner. And let's go. Let's turn this down.
Edmonton, our city, our news.
Tuner's working. Let's go to auxiliary and turn on the signal. Switch speakers. I only got one channel hooked up. Alright, so there's our clipping. And we are pushing out 19.1 volts RMS. We'll let this go for a while, see how it cooks. Okay, so it survived the 10-minute torture test, full power, and the heatsink's starting to get up to temperature. I don't think it's overly hot. The load is quite hot, so we're going to shut this down and let's do some frequency response tests. Go about half power. Let's start off with the low frequency. Let's go to 30 hertz. Subsonic filter doesn't have much effect. Let's take it down. (20 hertz). Subsonic bass control. And takes it back into clipping. Okay, let's zero that. Let's take it down to 15 hertz. Subsonic. Still has a slight effect. Let's take it down to 10. The purpose of the subsonic is to get rid of your turntable rumble and your low frequency feedback. Doesn't seem as sharp as some of the other receivers I've looked at. Let's take it down 7 hertz. Yeah, it's not quite as effective as most ones I've seen. Alright, let's go up. Now what we're looking for here is a drop off in frequency response. So let's look at, we're at 1000 hertz. Four thousand, 5, 6. 9, 10. 14, 15. We're at 20 kilohertz. What's going on there? Is that the scope doing that? What is going on with my scope? No, it went into protect. Doesn't like that. going in to protect. Getting some weird, I think my scope is buggered, to tell you the truth. Okay, let's go up higher. 21, 20 right now. 21. And here it starts dropping off. 34 kilohertz. 37. .7 volts RMS protection circuit kicks in, so it doesn't like that high frequency power output, but that's okay. That's far beyond what any audio signal contains, and that was just more like me abusing the amplifier. So everything looks good. Yeah, I got nothing to say other than that. I can't wait to test drive this one. It's a nice unit. Glad the tuner's working now, and we replaced caps in the power amplifier and power supply, so it should be nice, ready to go. Alright, well, thanks for watching, and tune in again next week for something else.